Water. Water is something that we're so familiar with, right? We drink it, we swim in it, we bathe in it, we cook with it, we just use it all the time. It's essential for life. And yet water is a very, very strange substance. It's an extraordinary substance. It has a very low molar mass, only 18 grams per mole, but it's a liquid at room temperature. And that's due to hydrogen bonding. Most compounds with a low molar mass like that are going to be gases at room temperature. It also has a very high specific heat capacity. The liquid is 4 joules per gram degree Celsius. That's much, much higher than most things. And that's important because it moderates our climate. Another odd thing about water is it expands when it freezes. Most things contract when they freeze, but water expands. Here's a more detailed graph like the one I showed you. So here we're looking at boiling point as a function of period in the periodic table. Here we have group 4, we've got the halogens, group 7, and we've got group 5 and group 6. And we see this nice trend for periods 3, 4, and 5. This nice trend that as you get smaller and smaller, the boiling point gets lower. As you go to larger elements, then the boiling point gets higher. And that's due to dispersion forces. Dispersion forces are stronger, they're more significant for larger atoms, larger molecules. And then we see this weird behavior for water, hydrogen fluoride, and ammonia compared to methane, which follows the line. We expect these all to be much lower than they are. What can these 3 compounds do? Hydrogen bond. ET, phone home, right? Here we've got hydrogen oxygen, hydrogen fluorine, hydrogen nitrogen. They can all do hydrogen bonding. And so their boiling points are much higher than is predicted from other trends. A little section in your book about water pollution. I'd encourage you to read that. I'm not going to talk much about it because we're short on time, and I'm not going to test you on it. But basically, there are 2 types of contaminants that cause water pollution. One of them is chemical, and one of them is biological. A lot of biological contaminants can be removed or caused to not be a problem by boiling the water. Right? If you kill the organism, it's not going to cause you problems anymore. That doesn't work for chemical contaminants. If you boil water that has chemical contaminants, sometimes that makes it worse because it can actually concentrate the pollutants.